All right, science fans, look around you. Do you see that? That dark shape following you on the ground? That's a shadow. Shadows are pretty cool, aren't they? They happen when something gets in the way of light. Light travels in straight lines. So, when you or a tree or a building block the light, this creates a dark area. A shadow. It's that simple. Light can't pass through you because you are opaque. That's a science word for something that doesn't let light through. Consider this. But wait. There's more to a shadow than meets the eye. Sometimes, if you look very, very closely, you'll notice that a shadow isn't just one solid dark patch. It can have different parts. There's a really dark part in the middle, and a slightly lighter, fuzzier part around the edges. These parts have very cool science names, the Umbra and the Penumbra. Okay, future scientists, it's time for activity 9.3. Let's create our own shadows so we can see these amazing parts up close. First, we need to gather our materials. You will need one small ball, tennis ball, rubber ball. Next, electric torch. That's a flashlight, fresh batteries. Finally, a screen, white wall, white cardboard. Let's get this experiment set up. Place your screen upright. This is where our shadow will appear. Take your ball, our opaque object. Hold the ball a little distance from the screen. Hold with your hand or mount it on a stick. Turn on your torch. Stand a few feet away and point it at the ball. Dim the room lights. Shine the torch on the ball. Look at the screen. A shadow. You've created a shadow. You are now a shadow maker. Observe the shape on the screen. It should look like a dark circle, right? You are controlling light and shadow, science in action. You are witnessing how light travels, how objects interact with it. It's a beautiful thing. Now, let's start experimenting. Don't just stand there. Move the ball a little closer to the screen, then a little farther away. What happens to the shadow? Keep the ball still. You move. Step closer to the ball with your torch, then step farther back. Does the shadow change? Does it get bigger, smaller, sharper, fuzzier? Pay attention to these changes. All right, let's take a closer look at that shadow you've made. Get your torch and ball set up again. Position the torch a moderate distance from the ball. Now, look carefully at the shadow on the screen. Do you see it? It's not just one shade of gray. In the very center of the shadow, you should see a part that is extremely dark. That, my friends, is the umbra. This is the area where the ball is completely blocking the light from your torch. Now, gaze at the edges of your shadow. See how it gets a little fuzzy and lighter? That fuzzy, not-so-dark region surrounding the umbra is the penumbra. In this area, the ball is only partially blocking the light from your torch. If you could stand on the screen in the penumbra, you'd be able to see part of the torch's bulb, but not all of it. This partial illumination creates the lighter, softer edge of the shadow. The penumbra is the transition zone between total darkness and full light. Let's play with these parts. Try moving the torch much closer to the ball. You should see the shadow get much larger, and the penumbra become much wider and more noticeable. The umbra might seem smaller or disappear completely if the light source is big and close. Now you might be thinking, Bill, this is cool, but it's just a ball and a flashlight. But what if I told you that you just simulated one of the most spectacular events in the cosmos? I'm talking about eclipses. The same principles of umbra and penumbra that you saw with your ball and torch happen on a planetary scale. Sun, Earth, Moon. The sun is our giant torch. The Earth is a giant space ball. The Moon is a giant space ball. It's the same science, just way, way bigger. Let's think about a solar eclipse. This happens when the moon passes directly between the sun and the Earth. The moon blocks the sun's light and casts a giant shadow on the Earth. If you are standing in the darkest part of that shadow, the umbra, you will experience a total solar eclipse. The sky will go dark, and you'll see the sun's corona. It's an incredible sight. But this umbra is very small, only covering a tiny path on Earth's surface. If you're not in the umbra's path, You might be in the much larger penumbra. In the penumbra, you see a partial solar eclipse. This is just like the fuzzy edges from our experiment. The same idea works for a lunar eclipse. A lunar eclipse happens when the Earth passes between the sun and the moon.